Okay, so we will cover our conics, the ellipses today. Just a reminder, the ellipses, we've got our ovals is what we're looking at. So you slice the cone at a diagonal there, okay, and you get an oval out of it, okay? Now, an oval is a little bit more interesting than just that, so we're going to cover that here. Your definition for an ellipse, okay? The definitions are what are important in this unit. Your ellipse is the set of all points P in the plane such that the sum of the distances from P to two fixed points is a given constant. Okay, that's our definition that we're going to revisit multiple times today. Okay. Set of all points P in the plane such that the sum, that means we're going to be adding something, of the distance from P to the two fixed points is a given constant. Those two fixed points in this case are going to be the foci. Okay, so there are two foci in this. We've already talked about the idea of a foci. It works very much the same. In this example, we have two of them when we have an ellipse. Okay. If foci are A and B, then the focal radii of P are AP and BP. Okay. So if we talk about our focal radii, I'm not going to get into that too much. Parts of the ellipse. So we've got the focus here and here. The vertices are the 2 points that are furthest away. If that means up and down, that means up and down, okay? But the vertices are the 2 points furthest away. And then we have co-vertices that are the 2 points that are the closest, okay? So you always have co-vertices and vertices, and the difference between them is simply that the vertices are further away, okay? And that's how you'll know kind of which way it goes. You also have a minor axis and a major axis. Those are axes of symmetry, okay? The major axis is the bigger one. The minor axis is the smaller one, okay? So you can kind of see those different ideas. Here's your chart. You don't have to memorize it, okay? If you want to highlight it, I don't know what you did on your parabolas, but this is your chart here, okay? I didn't give you one centered at 0, 0 because you can use this one centered at 0, 0, okay? So we've got this chart here. The difference between the two equations is simply the a squared and b squared on the bottom, okay? If you look at the top and the bottom line, the first one has a squared under the x squared and then b squared under the y squared, and the second one has b squared under and then a squared. Okay? And the difference in those, if you come across the chart, is that the a has to do with the vertices and the b has to do with the co-vertices. Okay? The a has to do with the vertices and the b has to do with the co-vertices. Okay? Since the a has to do with the vertices, that means the a is the bigger number, and I know some of this isn't going to make sense right now, but I'm trying to give you some ideas. Okay? A is the bigger number. That means that this is going to be the bigger number. So the difference in these two is if the bigger number's under the x, then you go with this one. If the bigger number's under the y, then you go with that one. Okay? And the difference in these two equations is it this direction or is it this direction? Okay? So this one is the top equation, horizontal direction, and this one is the second one, the bottom equation there, vertical direction. So those go together. The last thing to note here, and if you didn't highlight this section or you want to highlight this little piece here, it's this right here. If I give you the vertices and the co-vertices, you can find the foci, but you need that equation. Okay? It comes from x squared minus, a squared minus b squared equal to c squared. We could go into that. I'm not going to get into it too much. Just know that there's an equation there. If I give you the foci and the vertices, you can use that equation to find the co-vertices. Okay? So essentially the same thing with parabolas. I could give you any of the three of vertex, focus, and directrix, and you could find the third one. Here's the same thing. I can give you any of the three of co-vertices, vertices, and foci, and you can find the third one. Okay, but you have to use that equation right there. So if I'm looking back at the quiz review, remember I just keep coming back to this just so you have the ideas. The two things for today's stuff is derive the equation of the ellipse using the distance formula. Okay, so we're going to get to that one. And graph the equation, identify the vertices, co-vertices, foci of the ellipse. So you're going to use this on that second type of equation, number 7 on it. You're going to use this chart here, okay, in order to do that. Again, we're going to get to each of those different examples here. Before we do that, just answer this question. It's kind of like, is a rectangle a square, is a square a rectangle? So my question to you, is a circle an ellipse, and is an ellipse a circle? What are your thoughts there? Is a circle an ellipse, and is an ellipse a circle? Any thoughts on what the answers are going to be? Yeah?
I think it's yes for the first one and no for the second one, because a circle needs all points to be an equal distance from the center, but ellipses, I'm not sure what the definition is yet, but it's probably like,
Yeah, we just did the definition, you have it
is
highlighted.
it?
Set of all points P in the plane such that the sum of the distance
Oh,
from P to two fixed points is a given constant.
so probably because the radii is add.
Okay, so you got the first one right. This is a yes. Is a circle an ellipse? Yes, it is. Okay, if I draw a circle, it has a center point. Essentially, why it's an ellipse is because focus 1 and focus 2 are both this point. Okay, so is a circle an ellipse? The answer is yes. Is an ellipse a circle?
No.
So the answer is not no. Let me ask you this, okay? Is a square a rectangle? We say yes, right? That's the first question. Is a rectangle a square?
No.
Sometimes. Sometimes is the word we're going to use here. Okay? Is an ellipse a circle? If I draw my ellipse like that right there, is it a circle? Yes. So in that case it is. But if I draw my ellipse like this, is it a circle? No. Okay? So very similar to the square and rectangle argument. And one's a yes and one's a sometimes. Okay? I know it's kind of crazy, but we get the general idea there? Okay. So let's see what we can do here. Standard. Derive the equation of ellipse given the foci. So you're going to be given the foci. The other thing I'll tell you is we're not going to, in this one or the hyperbolas, we're not going to do it with all variables like we did with the parabolas. Okay, so the one we started with all variables and we had like the y minus k minus p and that kind of stuff. We're not going to go into that. You're going to be given a foci. Okay, so here we're given two foci. Using the fact that the sum of the distances from the foci is constant. Okay, so it says to find an equation of ellipses having foci at -4, 0 and 4, 0 and the sum of focal radii, use the distance formula. Okay, this right here is the definition of an ellipse. Okay, if you are doing this on the test, that is essentially what you're starting with. Now, the only difference is I put 10 here because it tells us that the sum of the focal radii is 10. Okay, I'm going to come back here and do this focal radii idea. Okay, what the focal radii is if I put a point here, this and this add to a certain amount. Okay, if I put a point here, I'll call it P2, this and this adds the exact same amount as that first set. Okay, so that's how you create an ellipse. So that being said, we can solve with this equation. The distance, what this is representing is the distance between P and F1 and the distance between P and F2. The sum of those is equal to 10. And that's what this is telling you up here. I'm going to show you guys a video real quick. Maybe. Okay, so we don't necessarily need the list for this. I just want to show you guys. So if you watch this, how to draw an ellipse with a string is if you look at this, you see the little points. Those are the two foci. Okay, so this is a foci and this is a foci. And if you draw a string around it, then that means that this distance plus this distance is always going to be the same, because that distance doesn't change. So if you have a certain size string, then it's going to stay the same at that point. So if you want to draw yours, this one not show it. No, hold on. I'm going to find a different one. I think this one shows it. Yeah, there you go. So if you want to draw your ellipse, all you essentially do is make two, give me a second, let me get into it. Okay, you make 2 points and then you tie the string to the pin. So you got the 2 pins, you tie a string. So this string right here represents that sum of the 2 focal radii. And then you put your pencil on the string and you start moving it. And if you see what's happening with hers, and I know it's a little bit hard to tell, but you're going to make an ellipse. Okay? Think about that. If you take a string and you attach it to 2 endpoints and you start moving around, this string, this distance of this string is not changing no matter where you put it around this area here. Okay? So that's where this ellipse definition comes from. We're going to look at a different video on the review day, but wanted to give you that general idea. So, we have to do the proof. This is essentially your copy of what you're going to have to do on the quiz. Okay? Can you show me the work through it? So write steps if you need to as you go through this. The distance between P and F1. Okay? P represents any point on the ellipse. What coordinates do we give that? XY, okay? P is XY. Okay, same as it was in a circle, same as it was in a parabola. Now it's in an ellipse, okay? Any point on it. So the distance between XY and focus 1 is -4, 0. Okay? So I do a square root of. Remember, I'm doing my Pythagorean theorem. I have a squared plus b squared equal to c squared. I'm taking the square root of both sides. So I'm looking at a squared plus b squared. Okay? If this is helping you, a is your run squared plus b is your rise squared, and that's your distance. So that's what I'm finding here. So I need to know the run. The run's the difference between the x's. So my -4 and my x difference is going to be x plus 4 quantity squared. It's x minus -4. So that's the same thing as plus. Plus the difference between my y's. I have a y and a 0. So I write y minus 0 quantity squared. Okay. In this one, it's not an equal sign next. It's a plus. I'm going to do another distance. I'm doing between P and F2. So F2 is 4, 0. Okay, so the difference between the x's is x and 4 is going to be x minus 4 quantity squared plus the difference in your y's. There's a y and a 0. So y minus 0 quantity squared. And those two distances sum to 10 is what this one tells us. Okay, that's your setup. Any questions? Okay, so you want to know, and some of you may want to, like this is an example, but that's essentially what you're doing in each of them. You may want to look at that. It's P F1 plus P F2 is equal to the sum of the focal radii, whatever it is. I have to give you that, just so you guys know. You don't have to find that. Okay, I have to give you that number. So I gave you that to be 10. Okay, so now it's your algebra. And the question is, what do? And you just have to be able to recreate these steps. Okay? What a lot of people think they can do here is they can square everything and get rid of the square roots. You cannot. Okay? It's the same as taking x plus 3 and saying that I can square both things and I can get rid of the square roots. You can't do that. You can't distribute this square that's right here. Okay? So you cannot do that. What you need to do is you need to get your two square roots on opposite sides of the equation in order to simplify them. Okay, so we're going to move one of our square roots to the other side. I went ahead and moved this one. It's not like it really matters which one you move. Okay, so to move that square root, I'm subtracting this square root to both sides. I'm not going to rewrite whatever's in there, but I'm essentially subtracting the square root from both sides. That's my first step. Okay, what's that going to leave me? And I'm going to simplify some stuff also. So I'm going to subtract and simplify. Okay, it's going to leave me the square root of x plus 4 quantity squared plus, do you guys all see that that simplifies? Y minus 0 quantity squared can be written as just y squared, right? Okay, we're going to simplify as we go here. Y squared, because we've covered some of this, is equal to, because remember those canceled each other out. Now I'm at the equal to sign. And on the other side I have 10 minus a square root of, and now I'm just rewriting this one here, x minus 4, I don't know anything about yet, so I'm going to say x minus 4 quantity squared plus y minus 0 quantity squared. I'm going to write as y squared. Okay. So you're getting your square roots on the opposite side, so you're subtracting and you're simplifying all in one step there. Okay, as much as you can. Now you can square both sides. So as much as you wanted to do it before, you couldn't do it before, now you want to square both sides. It's not as easy as it was with parabolas. Okay, you guys have the extra room over to the right just because then you'll be able to write down this one and then down the next one just so you guys know there's a blank one there for you. Okay, so you can square both sides. Now if I square this side, it does just what it did before. The square root and the square cancel out. If I square this side over here, okay, remember when we did this x plus 3 quantity squared, we can't just simply distribute the square. We have to do x plus 3 times x plus 3. Okay, so this is the main place where people will make mistakes. So let's see if we can not do that. Okay, follow me along. This side right here, I'm just writing everything without the square root. So I'm getting x plus 4 quantity squared plus y squared equal to. Okay, we have to multiply it out. Now you can write it out twice if that helps you, but essentially I'm doing first times first. Okay, the first times the second times the first, and the second times the second. So if that helps, you can kind of go with that. But I have to distribute this to itself. So 10 times 10 is 100. I have to distribute the 10 to the negative square root that's there. Okay? So I'm going to get and it's 10 times this, so it's going to be a minus 10 root x minus 4 squared plus y squared. Okay, so I just distributed the 10 to each part. Then I have to distribute the negative square root just to, I got a few funny looks there, give me a second here. Okay, right now I have 10 minus the square root times 10 minus the square root. That's I'll write it on here. Okay, I have this that I'm doing. If I'm squaring this, I'm doing 10 minus whatever this is times 10 minus whatever that square root is. So what I just did is I multiplied the 10 by the 10, got the 100, and the 10 by the negative square root, I got negative 10 root. Okay? Then I'm going to multiply the negative root by the 10, which is going to give me the same thing again. And I'm going to multiply the negative root by the negative root. Now, the negative root times the negative root. The negative times negative makes positive. And any time that you do, if I do square root of 3 times square root of 3, for instance, you get the square root of 9, you know the square root of 9 is 3. So anytime you do a root times a root, the roots just cancel and you have whatever's underneath. So now I have plus an x minus 4 quantity squared plus y squared not in a square root. Give you a second to look at that and ask if you have questions. Now, there's going to be enough writing in this that there's a few things that you can help yourself with. If you know that when you multiply this 10 by the root, get rid of that, there you go, the 10 by the root and then the root by the 10, that these two are like terms and they'll combine, and you could have written that as negative 20 square root of everything, okay, then you can definitely do that in that step. Okay? If not, we're going to do that in this next step here. So, we're going to do some more simplifying here. We just multiplied everything out, we're going to do some simplifying. What are some things that you notice that we can simplify in this entire equation? What can we do? Anything and everything that you can do here. Yes?
You can take the last two and subtract the x minus 4 squared and y squared and subtract it from both sides.
Okay, the x minus 4 squared, do you notice it's not the same as the x plus 4 squared?
Or the y squared then.
Okay, we can do the y squared. I like that. I just want to make sure we understand that, okay? The y squared, she's completely right. We have a y squared on both sides. Now, she's also got a point, so I want to point this out, okay? You notice your x plus 4 squared and your x minus 4 squared. And if you guys remember, 2 days ago, okay, we covered how if we have two things that we think can cancel some stuff out, we're going to multiply those out and we're going to go from there, right? Okay, so she's on to something. It's not that we're not going to do that. She's definitely on to something with that. Okay, so we have some different things that we can do with that. So let's go ahead and do that as we go through here. So we'll say simplify and multiply in one step. I like it. X plus 4 quantity squared. What's that going to become? Multiply it out. X squared plus
16.
No. Don't just distribute the square.
Plus 8x plus 16.
Good. Okay, this is going to become x squared plus 8x plus 16. Okay. Is equal to, I'm going across here, we can't do anything with the 100 yet, so we're going to leave that. Okay, I just told you that these two things are like terms. You could have written them together. If you didn't, we can write them together now, so it's negative 20. It's just like negative 10x and negative 10x. When you put them together, the two negative 10s come together. Okay, so the negative 20 root x minus 4 quantity squared plus y squared. Okay. Then keep going with that plus. Now we have this x minus 4 quantity squared, which becomes, go ahead.
X squared minus 8x plus 16.
Good. X squared minus 8x plus 16 there. I'm going to move this up. Maybe. Lets me. Okay, so we simplified, we multiplied, we did what we thought we could. What do you think next? What do you notice now? Yeah.
The x squared and now the 16 we can cross out.
Good, okay, we have something to cross out. Why did we just do what we did? Because we wanted to be able to cancel some things out. Okay? So we can do that. Okay? The other thing that I am doing right now is I'm trying to get my square root by itself. Okay? You wouldn't necessarily know this, but I'm canceling and I'm trying to get the square root by itself because I got to get rid of the square root to solve this problem. Okay? I also like to keep my square roots positive, so since this one is negative here, I'm going to move this plus 20 root, and I will write this, and you guys are more than welcome to. You know you're adding everything that's under that root, then you can just write the root symbol. And I'm going to add this plus 20 root to this side, but I want the root by itself as much as I can, so that means I need to get rid of that 8x. So I'm going to subtract 8x at the same time from both sides and move it to the other side. Okay? So what am I doing right now? I'm getting the root by itself. And simplifying, all in one. Okay? What does that give me? It gives me 20 times the square root of x minus 4 quantity squared plus y squared equal to, read across here, the 8x I subtracted, so it's gone. I added the 20x root, equal to, I have this 100. I got rid of this root that's here. I subtracted this 8x, so minus 16x. That's where I'm at. I keep checking to make sure I'm not making any mistakes as we go, you guys. There are some little algebra things that you may do wrong, so you want to check as you go. Does anybody notice something with all three? There's 3 terms up here on the board. What do you know about all 3 of those terms? When you look at algebra problems, you tend to look to see if you can simplify anything, right? Can you divide all 3 of those terms by something? What? 4, okay? If you can do that, it does make it a little bit easier, because in a second we're going to square again. And if you start thinking about squaring 100 and squaring 20 and squaring 16, those are getting to be larger numbers. You don't have to do this step, just so you know. Okay? But if you can simplify to make some of your numbers smaller, it does help. In this case, all of these terms are divisible by 4. Okay? So I'm going to simplify here by dividing. Okay? 20 divides by 4, so I get 5 times the square root of x minus 4 squared plus y squared. Equal to 100 divides by 4 gives me 25. Minus 16 divides by 4 and gives me 4x. Okay? I'm going to even write in here, you don't have to. You are going to have really large numbers if you don't, but you'll have a calculator in front of you and you can use it. Okay? So you do not have to do that step if you don't want to. And I will have plenty of students that will skip that step, so it's not like it usually goes half and half. Okay. I did that and I got that by itself because I want to get rid of my square root. Okay? I want the square root to go away. In these problems, your ellipses and your hyperbolas, you're going to have to square both sides twice. Okay? So we've squared both sides once. This is now the step where I get to square both sides again. So I'm squaring both sides again. Okay, when you square, let's say, I went too far. Okay. There we go. Okay, when you square, let's say 5x, okay, this is 5x times 5x, which makes it 25x squared, okay? When you square something like this, it works the same. It's 5 root times 5 root. So the 2 5's get multiplied together, and you get 25. And the 2 roots get multiplied together, just like the 2 x's got multiplied together. The 2 roots get multiplied together. And anytime you multiply 2 roots, the root just goes away. That are the exact same. Okay? So I'm going to, in here, have the quantity of x minus 4 squared plus y squared. Now, you don't have to use brackets like I just did. You can use just parentheses, but you're having 2 sets of parentheses. In math, when I run into 2 sets of parentheses, I tend to use a separate set of brackets, just so I can see the difference. Okay? But that 25 is multiplied by everything that's there, so you cannot leave those parentheses off. Okay? Is equal to, if I multiply something like 5 minus x squared, I cannot just distribute the square. I'm doing 5 minus x times 5 minus x. So I have to distribute this problem. That's what I'm doing on this right side. Okay, I have to do 25 minus 4x times 25 minus 4x. Okay, so 25 times 25, you're going to get 625, yes. You're going to get 625, okay? 25 times negative 4x, you're going to get negative 100x. Negative 4x times 25 is negative 100x. And negative 4x times negative 4x, two negatives makes a positive. 4 times 4 gives you a positive 16. X times x gives you an x squared. You thought, yeah, 2 days ago was a lot of algebra. You get a lot of algebra here, by the way. If you haven't figured that out, I want to make sure I haven't made any errors. 16x. Okay, multiply this out because things are going to cancel. I see an x squared. I see some x terms over there. I have some x stuff here. I'm going to multiply it out. Okay, so I'm going to do a few steps right here without doing the whole thing and then bring the whole thing back together. Okay, so x minus 4 times x minus 4. I'm going to get x squared. X times negative 4 and negative 4 times x makes negative 8x, and then plus 16, okay, plus the y squared. So that's what's in my parentheses here. Okay. I need to multiply all of that by 25. So distribute the 25 throughout. I get 25x squared minus your 25 times 8, so minus 200x plus your 25 times 16. Make sure I don't write this wrong. 400? Yeah. Plus 400 plus your 25 times y squared. Okay, so in these steps right here, I was just simplifying the left. Simplify, multiply, whatever you want to say here, the left side of the problem. Okay. And then I'm just going to copy down the right side here. Okay, so I'm going to bring all of this stuff down. So I have equal to 625. I'm going to combine these two. Minus 200x plus 16x squared. Somebody tell me the next step. What do you see? Connor.
Add 200x to those.
Good, so you can add 200x to both sides and we can get rid of them. Choose a different color. Try again, here we go. Okay? Those two will cancel out. He's right. Add 200x to both sides. Those two will cancel out. Now, I'm going to help you with the next step, and that is that you want to get all of your x squared terms and y squared terms on the left and all of your numbers on the right. Okay? So x squared and y squared to the left, numbers to the right. Okay, so I have 25x squared. I'm subtracting 16x squared over here. So I get a 9x squared. I got rid of that. Okay, I don't have a y squared over there. I just have this 25y squared over here. So 25y squared here. I want all my numbers to the other side. So I subtract this 400, subtract 400. I get equal to 225. So 9x squared plus 25x or y squared equal to 225. And your last step in ellipses, if you look back at your chart real quick, do you notice that both of those equations are equal to 1? You see that? Okay. How do you get this equation equal to 1? How do you get that 225 to become 1? There's two ways you can do it. One of them is correct, yes.
Divide by 225.
You're going to divide by 225. You could subtract 224. That's moving the number to the other side. We don't want to do that. The other thing you can do to get 1 is you can divide by 225. So you're going to divide everything by 225 because your goal here is to get it equal to 1. Okay? Just like the equations are. To set up an equation for an ellipse, you're going to have it equal to 1. So you divide everything by 225. If you need to do it in your calculator, please don't try to type in 9x squared. Type in 9 divided by 225. It's going to give you a fraction. In this case, it's going to be 1 over 25. So you write x squared over 25. Plus, do 25 divided by 225. It's going to give you a fraction of 1 over 9. So you write y squared over 9 is equal to, and 225 divided by 225 is simply, 1. Okay? That's your derivation of the equation. You can get to it. Now, that's the only derivation we're going to do here. Okay? You don't have to do another one today. So we're doing that one derivation. I gave you 1 or 2 on your homework to look through. Sorry, I'm trying to find it. I gave you 2. You only have to do 1, it's up to you. But I gave you 2 in your homework that you can look through. Okay? It's long, it's involved, but it's not impossible. Okay? And you get to look at that to do it again. You don't have to memorize it. What you have to be able to do is say, okay, she said she simplified and multiplied the left side. What am I doing here? What do I need to do? Can I redo it? Okay, can you remake that algebra that's happening? Okay, so that's what you're going to want to look over. You're going to want to try it on your own, and then go from there. And it does take a little bit, which is why the quiz is only 9 questions, by the way. Maybe we'll move on, maybe we won't. There we go. Okay, so the second one that you have to be able to do on the quiz, remember, is graphing. It says graph the equation, identify the vertices, covertices, and foci of the ellipse. So given an equation, graph it. Okay, so we're going to look at this, and we're going to look at our chart, and I know we're kind of going back and forth again. I'll try to talk through it or whatever, but we look at this. X squared and then y squared doesn't tell us the difference. So I'm looking at my chart, and you guys can flip to your chart while you look up here. That may be the easiest thing to do because I've got this page here. So if I'm looking at my chart, okay, doesn't matter if x squared is first or y squared is first. That doesn't tell me a difference between the top and the bottom row of my chart. Okay, what tells me a difference is which one's a squared and which one's b squared. Okay, and you may want to write this down on your chart, but a is always bigger. Okay, so this right here, since 25 is bigger than 9, this has to be a squared and this has to be b squared. Okay, which means that I'm on the top row of my chart. Okay. That is the way that you know which one of those charts you are using, is just simply based on the fact that a is bigger than b. Okay, so this is a squared, this is b squared. We're on the top row of our chart as we're going through this one. Okay, we want to graph the center of the 4 directional points, which are your covertices and vertices, and we want to connect, and that's all we have to do. So very similar to a circle. Okay, my a and my b help me find my vertices and covertices. So if you look through the chart, and I'm going to write them up here so you don't have to flip back and forth, but your vertices come out from h plus or minus a, comma k, and your covertices come from h, comma, k plus or minus b. So here's the nice thing. What's your hk in this one?
0,
0, 0. Do you notice there are no minus and plus with your x's and y's? Okay? It has been the same from circles to parabolas to ellipses, where if the x has something subtracted, that's either your center or your vertex, and if the y has something subtracted, center or vertex. Nothing here. So it's 0, 0. Okay? So if h and k are 0 and 0, it makes this pretty simple. And it makes this that the vertices then are just plus or minus a, comma 0, and then the covertices are 0, comma plus or minus b. Okay? So the vertices are plus or minus a, 0. What's a equal to? It's 5. You're exactly right. Okay? It's 5. Plus or minus 5, 0. So that's an x value of 5. So plus or minus 5. Let's do plus 5, 0 first. I go over here, I go to 5, 0. That's one of my vertices. I go over here to negative 5, 0. That's my other vertex. Okay, there's my vertices. If you want to label them, you can. You don't need to, but you can label them. Okay, my covertices are going to be at what? Good, they're going to be at the 3's. 0 plus or minus 3. Okay, so it's 0 first, so that means that if the 3's in the second spot, it's going up or down 3. So I'm going to go from 0, 0 up 3, and I'm going to go from 0, 0 down 3. Those are my covertices. My center, sorry, I didn't graph my center. My center was 0, 0. I have my 4 directional points, and I connect. Okay. Could you, if I look back at what the quiz asks you for, could you identify the vertices, identify the covertices, hopefully yes, and identify the foci? If you're going to identify the foci, you're looking at that equation that said x squared minus, or sorry, a squared minus b squared equal to c squared. Right? In this case, my a is, my a squared is 25 minus my b squared is 9 is equal to c squared. That's going to be 16, and that means that my c value is 4. Okay? I look at my chart, my foci say that they are at h plus or minus c, comma k. We just identified h and k as 0 and 0. Okay, so the foci are at plus or minus 4, comma 0 if I fill it in. So could you identify those? That's all you have to do to be able to identify them. Okay, I gave you one more just to kind of practice on this, the graphing, because these are a little bit quicker. Okay. if you have an equation of ellipse, if you want to know if you have an equation of an ellipse, okay, it should be able to be written as x squared over some number plus y squared over some number equal to 1. Okay? So the very first question on the quiz is going to ask you to identify, is it a circle, is it a parabola, is it an ellipse, is it a hyperbola? Okay? At this point, you know that the parabola is because only x squared or y is squared, not both of them. Okay? That's an easy one. Okay? The circle is going to allow you to say that it's x squared plus y squared equal to some number. There's not going to be anything here, there's not going to be anything here if you have a circle. Okay? Your ellipse is going to be, there's not going to be anything here, not anything here, but there's going to be a number on the bottom equal to 1. Okay? With a plus sign right here. We're going to get to hyperbolas tomorrow, or Monday, but there's going to be a minus sign there if it's a hyperbola. Okay? So that's the difference. We'll go back through that on the review day, but those are the things you're looking for. So we want to make this into our ellipse. How do we do that? We get it equal to 1. Okay, so the first thing you need to do is you need to divide by 64 to set it up into the correct form. You should get x squared over 16 plus y squared over 64 is equal to 1. So yes, this is an ellipse. Now, without using my chart, I want to show you guys a little bit of a trick here. Okay? If I go in the order that this is, I don't know which one's A or B right now because I'm not using my chart. Okay, and I'm not remembering that A is bigger than B, anything like that. All I know is that this is a square, so I got to find the square root of that, which is 4. And the square root of this is 8. Okay? I'm going to make a point out of this one. Okay? This one, since it is first, goes in the first spot with a 0 in the second spot. This one, since it is second, goes in the second spot with a 0 in the first spot. Those are my co-vertices and my vertices. Could you tell me right now which ones are your vertices? The what? Which ones?
The one on the right.
The one on the right, the ones with the 8, the ones that are bigger. Okay? I didn't use the chart at all. It is simply this. If it's in the x squared and then the y squared, as long as it's set up normally like this, okay? And you're dealing with the x squared and the y squared, whatever's first goes in the first spot with a 0 in the second spot. Whatever's second goes in the second spot with a 0 in the first spot, and those are your points. Okay? Center is still at 0, 0. I can go to plus or minus 4, 0, so I can go to 4 and 4. I can go to 0 plus or minus 8, so go up to 8, down to 8, and I can connect them. And I have myself an ellipse. Okay. Could you identify your vertices, your co-vertices from that? Could you solve that equation for the foci? Hopefully yes. Okay, so hopefully you're figuring out, in every one of these we have a derivation problem and then we have a simpler problem. Get the simpler problems down, understand those, but ask if you have questions on them. And then know you might make a mistake or two on the derivations, but you can also do those. Okay, you guys know how. You can follow your steps there. So the last one, find an equation of ellipse having x intercepts 3 and negative 3, and y intercepts 4 and negative 4. Okay. So x intercepts 3 and negative 3. As soon as I see that, I think to myself, okay, I have this plus or minus 3, 0. And y intercepts, that means 0 for x, is plus or minus 4. Take what I just taught you and let's reverse it. I'm not using the chart. Okay? I know, the only part of the chart that I'm using is I know that the general form for an ellipse is x squared over something plus y squared over something equal to 1. Okay? If I know that my x-intercepts are at plus or minus 3, 0, and then y-intercepts 0 plus or minus 3, I'm pretty sure it's centered at 0, 0. If you notice all these that we've been working with, centered at 0, 0. Okay? You're going to be dealing with those. Okay? So I've got that, so I don't have to worry about a plus or minus up here. But then I fill it in. If I use what I just did, what am I filling in?
Under the x squared it'd be 9, and under the y squared it'd be 16.
Good. Since this one is second, you square it, you put it under the second one. Since this one is first, you square it, you put it under the first one. That's all it is. Okay? So if you want to use the chart, great. If you want to write down what I just said and that helps you, okay, the first and the second idea, then yes, you can definitely do that too. Okay? So that's what I have for you guys today. You've got your homework that you can work on. Again, there's 2 deriving problems. I will just tell you, you don't have to do both of them. Again, it's your open note stuff to do. But if you think both of them will help you, then do both of them to make sure that you know what you're doing come quiz time. Okay? you've got some time, don't necessarily have to start it right now, but wanted to give you guys that opportunity there, okay? Let me know if you have questions.